Hi dear students, welcome to Gita's classes. In this class, we are going to see more examples just for understanding the concepts of predicates and quantifiers. So, first example, express the statement, every student in this class has studied calculus. So, we are going to express this statement using predicates and quantifiers. So, just for clarity, first let us write the statement, rewrite the statement according to our requirement. Now, we are going to quantifiers are for all and there exist quantifiers are there. So, here every student, so we are going to use the universal quantifier. So, let us write this for according to our requirement as the same statement can be written as for every student in the class, for every student in this class, that student has studied calculus. That student has studied calculus. We can write like this, right? That is, we are going to express in terms of predicates and quantifiers. So, we are going to use the variables x and all. So, in for more clarity, here for we know that every is used. So, we are going to use for all only. Now, next is for every student in terms of x if you want to express. For every student x in this class, x has studied calculus. X has studied calculus. So, now we are going to decide the domain of discourse. If you are considering the domain of discourse as the students of this class, okay, if that is what is domain of discourse, from which you can take x values. X is a variable which can be taken from which set, okay, that is called the domain of discourse. So, if you are considering the domain of discourse as the students from this class, then we can write, before that let us write this exam. Now we are going to define C of x as x has studied calculus. X has studied calculus. So if x is a student from this class, we are going to consider the domain of discourse as the students from this class, students in this class. Then we can write for all x, C of x, right? But sometimes it may not be, it can be extended. We are going to consider a wider set of people. Any from outside the class also we are going to consider all the people, okay? So in general, if you are considering any person, then we have to rewrite the statement as for every person x, if x is a student of this class, student in this class, then x has studied calculus. This is what we are going to write. So let us write S of x as x is a student in this class, because x we are considering the wider set of people, not only students from this class. If we are considering only the students from this class as the domain of discourse, that is x can be taken from the set of students in this class only, then you can write for all x, C of x, okay, they have studied calculus. Now x can be taken from not only from this class, other class also, or outside the class. Any person can be, right, any people, okay. If you are considering the set of all people, then if he or she is a student, then only we are going to consider they have studied calculus, right? So if S of x is a student in this class, X is a student in this class, then our required statement will be, if X is a student of this class, then he or she has studied the subject calculus. Okay. Now you may get a doubt whether we can consider this statement instead of this. Now what we have written? You are considering any person, and if that person is a student, then he has studied calculus. He or she has studied the calculus, studied the subject calculus. Now instead of that, can we write, you may get a doubt, why don't we consider S of X and C of X? Can you consider like this? So you should know when to write conditional, when to write and. Okay. So S of X and C of X, if you write, if you consider any person X, X is a student of this class. This means X is a student of this class and X has studied calculus. But this is not the statement we want, right? Here that means all the people are students of this class only, and all the persons are studying calculus. Okay. So that is not the case. That's why S of X and C of X we are not supposed to write. So we have to write, if you are considering a person, that person is a student of this class and that person studied, then if he or she is a student, if the person is a student, then he or she has studied calculus. Okay, that is the meaning. That's why you are not supposed to have, this is wrong. You are not supposed to have this S of X and C of X. Okay. Next we will see one more example. Now express the statement. There are two statements. One is, some students in this class has visited Hyderabad. And second statement says, every student in this class has visited either Hyderabad or Chennai. So if you are writing, some students in this class has visited Hyderabad. So first let us write this statement. That means there is a student X in this class having the property that what is the property we are talking about? That X, okay, the student. So X has visited Hyderabad. That means there is at least one student. There is a student X in this class having the property that X has visited Hyderabad, right? So if you are defining this variable as H of X, that X has visited Hyderabad. Okay. Then how will you write this? There is at least one student. Now you consider the domain of discourse. If the domain of discourse considers you are considering the domain of discourse as only the students from this class, how will you write this statement? There is at least one X such that H of X. Okay, this is our statement. There exists at least one student from this class, H of X. No, now we are going to consider the wider set of people other than this class also. If you are considering the persons from other than this class also, then how will you write the statement? There is a person X having the property that X is a student in this class. X is a student in this class and X has visited Hyderabad. Okay. So if you write, now we are going to define one more variable S of X, that X is a student of this class. X is a student of this class. So now what will be the statement? There exists X, there is a student. that X is a student of this class and visited Hyderabad. Okay, so now we'll get a doubt. In the previous one, what we have written, for all x, s of x, conditional c of x. Now there exists x, s of x and h of x. Now in this statement, can you write there exists x, s of x, conditional h of x? So no confusion, because see, suppose if you write like this, there exists x, s of x, conditional h of x. What is our statement? At least one student in this class. There is some students in this class. At least there is one student from this class has visited Hyderabad. That is our then. Now, if you write the statement like this, there exists x, s of x, conditional h of x. That means if you are considering s of x is the statement that it is a student. S of x is x is a student, right? Now, if you consider s of x as a student who has not visited, if you consider, we cannot write like this. I'll give you the reason, because it will become true even if there is someone, if there is some student. It will become true if there is some student who has not visited, sorry, there is some, sorry, there is someone not in the class, not a student, because our consideration is anyone, right, any x. So if you are considering someone not in the class, then this s of x, conditional h of x will become true, that is f, okay, not the student. S of x means what? S of x is a student of this class. So there is someone not there in the class means s of x will become not s of x, that is false, right? And even if h of x is true, someone outside the class who is not a student of this class also, f conditional t, and who has visited Hyderabad, someone who is not the student of the class who has visited Hyderabad, or who has not visited Hyderabad. In both the cases, f conditional t and f conditional f both will become true, right? Both are true. In both the cases, this s of x, conditional h of x will also become true, which is not correct. Okay. Actually, what is your statement? There is a person, some student in this class has visited Hyderabad. So he should be a student and he would have visited Hyderabad. So there is at least one student, there exists a student who, there exists a person x who is a student of the class and who has visited Hyderabad. Okay. Understood? I hope you have understood. Actually, only for TF combination it is false. T conditional F it is false. For all the combinations it will become true. So FT combination, FF combination it will become true. Okay, which is not correct. Right? That's why you are not supposed to write again here. This is, you are not supposed to write there exists x, s of x, conditional h of x. Hope you would have understood this. Now let us do one more problem. Prove or disprove the following arguments. All integers are rational numbers. Some integers are powers of 2. Therefore, some rational numbers are powers of 2. So first let us write in terms of mathematically we will write, express logically. So these statements I am going to define. Here you have integers, rational numbers, powers of 2. So let us define. I of x is an integer. And I am going to define r of x as x is a rational number. Rational number. And p of x is x is a power of 2. right? So the given statements are all integers or rational numbers. Therefore, the given statements are first one is all integers or rational numbers. So I of x, as we have seen in the first two examples, I of x conditional R of x for all x. All integers are rational numbers. Next is some integers are powers of 2. So there exists x, I of x and p of x. Powers of 2. So p of x is defined as x is a power of 2. Okay. Therefore, so now these two are premises. And the conclusion is, what is the conclusion? Some rational numbers are powers of 2. So there exists x, R of x and p of x. Right? There exists x, R of x and p of x is our conclusion. So from these two premises, whether the conclusion follows or not, the argument is valid or not. That's what we are going to see. So this is our H1, premise 1, premise 2 and this is our conclusion. Okay. So let us introduce all the premises one by one. So first step is for all x, I of x conditional. First let me introduce the first premise, I of x conditional R of x. Yeah. So now what am I doing? I am introducing a new premise, therefore rule P. From this I can write, please remember all our implications and equivalences we can apply only for particular values, not for with statements with quantifiers. Okay. So from this I can write I of r, a particular element, this is true. Okay. So let us see that I of c, we are considering one element R of c. Okay. So this is from universal quantifier I am writing for a particular element. So universal specification we can say, rule US I have applied in the first statement. Universal specification you can say, or universal instantiation also you can write. So now let me introduce the next statement. There exists x, I of x and p of x. So there exists x, I of x and p of x. Okay. Now I am introducing a new premise, therefore it is rule P. From this again existential quantifier is there. I cannot apply our rules, implications and equivalences to this with quantifiers. Okay. So I have to write, this is there exists a particular value c for which this is satisfied. So I of c and p of c. Okay. This is from existential quantifier I am writing for a particular element, specified element. So existential specification. Okay. From further step 3. From step number 3. So next from 4 I can write I of c. That is rule T. It is a formula. I can write it as simplification. I have applied in step number 4, simplification. Next is 6. I can write, that is P and Q implies P, P and Q implies Q. I1 and I2, simplification. Okay. So again rule T I have applied in step number 4. The same simplification only. So what is simplification? I1 and I2. P and Q implies P, P and Q implies Q. So from this now, here I have I of C and in step number 2 I have I of C conditional R of C. That is P comma P conditional Q. Therefore P comma P conditional Q is what? Q. That is R of C. Right? So this is rule T. I have applied in step number 5, comma 2, I11 modus ponens. Okay. All these implications I have explained in my classes in unit 1. Okay. So now we have R of C and P of C, right? R of C and P of C. That is what we want, right? R of X and P of X, there exists X. So for the same value of C, you can write R of C and P of C. That is rule T. I am applying a formula from 6, 7 in steps number 6, 7. That is I9 conjunction. Okay. So now for at least one value it is true, we have proved. Therefore from this I can write there exists X, R of X and P of X. From one element I am going to write the quantifier. Therefore it is rule existential generalization. I have applied in step number 8. Okay. So generally for university exams the questions will be like this only. They'll give you the English statements. You have to write the corresponding quantifier using predicates and quantifiers. You may be asked to write, and you have to check the argument whether it is valid or not. Validity of the argument also can be checked like this. Okay. Hope you understood. One more problem we'll see. Write the negation of the following statement in 2 different ways. Actually, negation when you are writing for quantifiers, if you have there exists, please remember there exist will become for all and for all will become there exist. Okay, negation of there exist will become for all, negation of for all will become there exist. Similarly, by using De Morgan's law, you can apply not or and will become or will become and. I'll give you one example. Every student in this class is intelligent. So how will you express this? If you are writing I of X as X is intelligent, and consider the domain of discourse as the set of all students in the class only, then you can write for all X I of X. Okay. And if you want to write the negation of this statement, so given statement is for all X I of X. So negation is negation of this statement is negation of, you can write just like that, negation of for all X I of X. That is, if you write like this, how will you write in English? Not every student in this class is intelligent. Okay. Or if you apply negation, this is if you want to write the same statement as in English, not every student in this class is intelligent. Or if you apply this negation inside, then it will become there exists X, not of I of X. Negation of I of X, right? That is, some student in this class is not intelligent. There exists some student in this class who is not intelligent. Okay, so this is the negation. And one more thing, if you have for all X, negation if you want to write for all X P of X, this will become negation of this is equivalent to there exists X negation of P of X, and negation of there exists X Q of X is equivalent to there exists will become for all X and a negation of Q of X. So generally the common mistake people do is they will forget to write this negation before the variable. So don't do that. So for negation, if it is applied for all will become there exists will become for all. Okay. Hope you understood, and it will be useful. I think it will be useful for you. And please give a like for this class and share it with your friends so that it will be useful for them also. Thank you so much for listening.